Thank you very much. Moving right along, moving into session 4. This is the New School of Security. We have a couple of presentations for you. And the chair of these sessions is Sam Visner. He's a director of National Cybersecurity Federal-Funded Research and Development Center at MITRE. So, Sam.
Thanks a lot. Appreciate getting here. And also, since our sponsor of our federally funded Research and Development Center is the NIST National Cybersecurity Center of Excellence, I was pleased by the earlier comments. We like getting good press, which, as you know, in the cybersecurity business is all too rare. Generally, we wake up. We are, I think, in our business, we are the national distributors of bad news, right? So I'm really honored to be here today, and I'm really pleased to have two really distinguished panelists. Each of them is going to give their own presentation. We're going to ask that you hold your questions until after both presentations have been given to be sure that we have enough time for both. Let me first introduce them to you, and then I'm going to tell you the questions which I didn't tell them that they were going to have to answer. Eric Jardine is a CG Fellow at the Global Security and Politics Program and Assistant Professor of Political Science, so a cybersecurity and political science guy at Virginia Polytech and State University in Blacksburg. He joined CG as a research fellow in 2014. He holds a BA in political science from the University of Calgary and an MA in political science from Carleton and a PhD from the Norman Patterson School of International Affairs at Carleton University. He has written on terrorism and political violence in the Journal of Strategic Studies, and his current research focuses on war, weariness, and conflict outcome, as well as cybersecurity, cyber terrorism, cyber protest, and other things. He's written and is working on a dissertation called The Insurgent's Dilemma, which, in fact, I think I like to read because I think being an insurgent is a whole lot of fun, well, as long as you don't get hurt. Jean Camp, our other speaker today, hails from Charlotte. She's a professor at the Indiana University School of Informatics and Computing. Her bio is so distinguished and so long that it doesn't even it's too long to read, but she's been an associate professor at the Kennedy School, and she has been at Sandia National Laboratories. Her best-known work combines efforts on computer science and social sciences and work on the economics of security. There's a lot more I could say, but you can read their bios as well as I can, particularly if you go to that thing called the internet. So I'm hoping, though I have no particular expectation one way or the other, that there are some questions that you're going to talk about, because I get these questions from time to time, and when I've run a couple of cybersecurity businesses and actually sent bills to people, I'm pretty sure these questions were lurking in the back of their minds, if not the front of their minds, and that is, how should cybersecurity risk be monetized? What should an organization be prepared to spend? What is, as a friend of mine would like to say, what is a pound of cybersecurity worth, or if you're in Europe, a kilo of cybersecurity? Is perfect cybersecurity really unachievable or unaffordable? I teach as an adjunct at Georgetown, and I make my students think about the concept of an asymptote, where you keep spending more and more money to get diminishing amounts of cybersecurity. Do we really have to operate like that? In a world in which cybersecurity is often voluntary and its risk is seen as something we try to amortize, can create the conditions under which the economics of cybersecurity actually make some sense? I've been thinking about this for a while. I can't say I've gotten nearly as far as I should have liked. So with that, let me turn this over to Dr. Jardine. And then, Eric, when you're done, if you please turn the podium over to Jean Camp. Please join me in welcoming Dr. Eric Jardine.
Thank you for the introductions. As my bio obviously makes plain, I'm a political scientist by training, but I have a love for numbers and measurement, which sort of brings me to the general topic that I'm focusing on today, which is the problem of aggregated security trends or cybersecurity trends and this statistical phenomenon known as Simpsons Paradox. I think it's kind of a cool little problem, and I come at it via some Monte Carlo simulations that I think can shed some light on where we're at as a wider ecosystem in terms of understanding trends in cybersecurity. So by way of just a quick overview of what I'm going to go through today, I'm going to point to a few of those worsening aggregate trends that we've all sort of pointed to or alluded to or outright stated during the course of today. Then I'll talk a little bit about the argument that I'll make during the course of the presentation, but that's also found in the associated paper. Talk about the assumptions or conditions for the modeling that I do. Skipping over the data stage just in the interest of time, but it's in there if we need to pivot back to it at some point, and then talk about the findings and the ways forward or the implications of what I come at during the course of the simulations. So at many points, we've talked about how bad things are getting over time. And I think this sort of gut reaction, often backed up by some form of statistics, is really easy to substantiate if you just you type in cybersecurity statistics and you start to look for whatever's publicly available on the internet. So you could find, for example, Privacy Rights Clearinghouse data on data breaches in the United States. They record the count of the breaches per year, and they also record the number of breach records. The count's kind of flat, but the number of records is definitely starting to escalate near the end of the years that I have data up until 2016. You've got a pretty strong worsening trend. That fits with that sort of gut instinct that there's the things in the cybersecurity environment are worsening over time. If you looked at vendor reports, you're going to get the exact same kind of story. So Symantec's most recent vendor report indicated an 8,600% increase in IoT attacks from last year. If you look at a wider lens on over a span of years from Kaspersky Labs and from Symantec, you get the same sort of story. Blocked attacks, web-based attacks, they're generally going up over time in terms of what's being observed in the wider ecosystem. From 2008 for Kaspersky, which is the longer term line here, to the peak, you have about over a 7,000 percentage point increase or 7,000% increase in the number of attacks that they were observing. So you have some pretty significant indicators at an aggregate level that there's a worsening cybersecurity situation, which I think fits with the motive for the conference and basically our sort of gut intuition when we sort of look at the news and things like that. Now, while all of this is relevant, why I'm going over trends and ground that I think is probably pretty well worn for everybody in the room is that it links to the core argument that I want to try to make or try to get at. And that's the idea that aggregate statistics can actually be, under some certain set of conditions, very misleading. So much so that you might end up seeing a worsening overall trend that's actually based on disaggregated improving trends. And I'll talk a little bit about what I mean via, I think, an interesting example from the non-cybersecurity space. So 1983, the Reagan administration had commissioned the National Commission on Excellence in Education. And their job was basically to look at education in the United States from K through 12 and to basically assess the situation and come up with policy recommendations, as national commissions are wont to do. They ended up publishing their report in 1983, and it was called A Nation at Risk. And it was called A Nation at Risk because they had documented what they called a rising tide of mediocrity in the K through 12 education system in the United States. And they based that finding and all the subsequent fairly radical policy overhauls to the education system in the US on an observation of aggregate SAT scores. And what they'd observed is that over the sample period that they had, SAT scores were worsening, particularly in the areas of reading comprehension, which is kind of important, and mathematics, which is also kind of important. And so what they basically found was SATs were declining over the period, and they suggested, well, the education system's failing. It's not keeping up with educating young people for modern times. And that's fine. If the aggregate trends had been correct, then the sort of policy overhauls that they were suggesting would have made some sense. An independent research team, however, took a second look at the data, and what they did was actually disaggregate the aggregate SAT scores based on quintiles of classroom performance. A good predictor of how you're going to do on the SAT is how you generally do in high school. And so they disaggregated into, say, the top quintile of all the best performers at the high school level and the worst performers with the other 3 quintiles in between. And what they found when they looked at this disaggregated data was that SAT scores across each quintile weren't actually worsening. In many cases, it was either flat over the sample period or in a few of the cases, actually improving, suggesting that SAT scores were actually going up rather than going down. Well, how they ended up reconciling the fact that the aggregate trend was worse and the disaggregated trends were generally positive was that more people from the bottom quintile, those people who previously hadn't been taking the exam, had started to take the test. And so the aggregate numbers, which were based on everybody just taking the test, indicated this worsening situation, but it was driven by more people at the bottom participating in the test. And this, I think, has some pretty interesting analogous implications for cybersecurity. And so we could actually see a situation, and I'll show the conditions under which this matters, where you have aggregate statistics like the ones I pointed to before that show one thing that are maybe based on the exact opposite sort of trends when you disaggregate the data across the right sort of confounding variables. And so in other words, we have to maybe be aware of at least, and if not, if we have to be aware of, if not somewhat wary of the problem of potential aggregation bias in cybersecurity statistics. And so as I said, there's 3 conditions that I'll talk about in just a second here, that if these hold, the possibility of Simpsons Paradox is very real. Those conditions, I think, are fairly straightforward. The first is, like with what the Sandia National Laboratory people did when they disaggregated SAT scores, you have to be able to disaggregate breachable points along the network. So you have to be able to say that there are some sort of categorization you could do, perhaps according to, say, vulnerability, that would make some sense conceptually. And if you can do that, if you can divide up points on the network, then you can satisfy this first condition. For the modeling, I call it savvy users, naive users, and IoT devices, which is a very crude categorization, but it's just an example of what you would need to do in order to satisfy this first condition. The second condition is you have to have some sort of ordinal ranking there. Quintiles in a classroom are naturally ordinally ranked from the top quintile to the bottom quintile. If you can do something similar in terms of ranking by vulnerability, you've satisfied this second condition. And the last condition, this fits with what we saw when the bottom quintile was taking the test more and driving down aggregate statistics. The worst performing group has to be growing the fastest over time. So to sort of foreshadow what I'll be getting at, if you have, for example, highly insecure IoT devices, and they're the most insecure and they're growing the fastest, the chances are something like Simpsons Paradox could be in effect. And so what I did, I'm just going to skip through the data, but we can talk about it if you want, just to sort of get at some of the nitty-gritty, but for the purposes of just generally understanding what I'm saying, not overly important. So I used a series of randomly simulated numbers based roughly in empirical trends in order to try to document or showcase what I'm talking about here. I think it's useful to just point to a one-off run in a normally distributed world where I assume a normal distribution for cybersecurity events in order to showcase what I'm talking about. This is the aggregate trend for the simulated data over a one-off run. You basically have a generally increasing proportion of the population that's being predicted as being breached in this particular set of simulations. The interesting thing is that this generally positive aggregate relationship is based on 3 disaggregated relationships across savvy users, naive users, and IoT devices that all point in the opposite direction. So this data, this positive relationship or worsening cybersecurity trend is based on a strongly negative trend among the savvy user category where they're becoming less vulnerable over time, a strongly negative trend in the naive user category where they're becoming less vulnerable over time, and a strongly negative trend in the IoT category where they're also becoming less vulnerable over time. So consistent with the nation at risk sort of example from the education sector that I talked about, a one-off run of the simulated data shows the exact same thing, that those 3 conditions being satisfied by the randomly generated numbers I used, you ended up with a worse aggregate trend and improving disaggregated trends. Now, one-off random numbers can simulate anything, and so I ran this 1,001 times in order to sort of get at, when we really look at this multiple times over, what are we seeing? And so here in the table, you have the results of the 1,001 runs in a normally distributed world. Again, this assumes normal distribution to the breaches as they occur across the population. And the far most left, my left, your right column, has the sort of aggregate numbers across the 1,001 runs. You have, like the one-off run in the figures indicated, the savvy user camp, the naive user camp, and the IoT device camp, all proving in the sense that a smaller proportion of the population is estimated as being breached. But when it gets aggregated together because of the shift in the population base and the way in which IoT and naive users are growing relative to savvy users, you end up with a 16 percentage point worsening trend. And so you have, across 1,001 runs in a normally distributed world, the possibility of Simpsons Paradox, effectively reversing the signs, saying aggregate trends are worsening when in fact across all the subsidiary categories they're actually improving. The other way I modeled this, because I don't think cybersecurity events are actually normally distributed, was to use a power law distribution, which is much more prone to extreme sort of fat tail distribution with huge outliers. And in this case, as sort of fits with both of what we see in terms of mega breaches of several billion records, plus what we know about power laws in terms of their level of how extreme they get. The same pattern holds, so that the emergence of Simpsons Paradox doesn't seem to be sensitive to distribution type or assumptions about distribution type in terms of the occurrence of events. But you tend to see an even more pronounced difference between what the disaggregated trends and the aggregated trends indicate. So here you have 8.8 percentage points improvement for savvy users, 14.8 percentage points improvement for naive users, and a 5.1 percentage point improvement for IoT devices. And that, when aggregated together, gets married into a 21.3 percentage point worsening, or 21.3 percentage points more of the ecosystem gets breached in the aggregate. And so again, different distribution type, but the same basic problem, that once you have these sort of lurking confounders of vulnerability and growth sitting within the data that's aggregated together, you end up with some pretty severe distortions in terms of the view that you get. So what does all this mean? As I said, I'm a political scientist who likes measurement, and so I come at this with an eye towards how measured trends can affect policy. And so if you have the observation of aggregate statistics suggesting things are getting very, very bad very, very quickly, but the possibility that maybe they're not, then we get into an interesting world where there's some interesting conclusions to be drawn from these sorts of simulated runs at the data. And so I think there are three main lessons, actually four, now that I think about it. The fourth lesson is it's always possible for an aggregate worsening trend to be based on disaggregated worsening data. That is a possibility. So I'm showing the possibility of Simpsons Paradox, not the actual existence of it necessarily, but I'll circle back to that in a second. The first of the lessons is that we should probably be taking aggregate statistics, at least, with a little bit of a grain of salt. That there is this possibility of Simpsons Paradox, or the Simpsons reversal, or Yule-Simpson effect, or aggregation bias, however you want to call it, that could be clouding the view. It could be suggesting that things are heading in one direction when if we looked at it from the right lens, things are actually looking the opposite way. And why that matters is that if you're using the aggregate trend as a guide for heavy-handed policy, if you're saying, well, the sky is falling, so we need to start regulating, that could lead to problems, as it sort of did, and I don't want to get into a big debate about education policy, but radically overhauling the US education system in response to perceived worsening of SAT scores when people were actually tending to do better over time was a bit of a knee-jerk reaction. And I'm worried about the same sort of thing in this space, that from a political standpoint, a worsening trend requires a big response, but the trend might not actually be worsening if Simpsons Paradox is actually in effect. So the second lesson that can be extracted from this is that Simpsons Paradox is not random in terms of where it emerges. It hinges on this problem of lurking confounders. And so classroom performance is a lurking confounder of SAT performance. So if you don't condition on how well people do in high school, when you look at SAT scores, you're not going to get a good sense of what the trends are over time. Likewise, if you're not conditioning on vulnerability, and when you're sort of looking at trends in the wider ecosystem, you're going to end up with the potential for Simpsons Paradox to be seeping in. So we want to be conscious of this lurking confounder problem because it can definitely bias what we're talking about. And it's not just overtime trends, I should add, that are prone to this sort of thing. Medical research often falls prey to Simpsons Paradox, and there's a very good reason for that, because the lurking confounder for medical research is the problem that worse diseases tend to be that there's a selection on disease type. So if you're very, very sick, you're going to get a certain suite of treatments. And if you're not that sick, you're going to get probably a different set of treatments. And so when you look at the effect of those treatments on mortality or morbidity, you can inadvertently conclude, if you don't condition on how severe the disease was, that those extreme treatment types aren't that effective. But you have to take into account the fact that they're dealing with the most extreme sick people. The same sort of thing here, if you're not conditioning on vulnerability and you're trying to talk about the effectiveness of a policy or protocol or new technology, if you're not paying attention to this is already the most vulnerable camp of devices, say, then you're not conditioning on the right variable and you could misidentify the effectiveness of a policy. And the last, and this is, I think, the most tentative, because as I said, aggregate worsening trends can be based on disaggregated worsening trends as well, but radically disjunctive policy might not be warranted. One thing that I've liked about the course of today is that nobody's really come out and said we need to do anything too crazy when it comes to on the regulatory front, that there's been, I think, a very bottom-up sort of view of the effective role or the right role for policy. And I think that my results from the simulated data here sort of suggest the same sort of thing, that there's reason to be cautious. Doesn't mean everything's fine, just reason to be cautious, and we need to pay attention to that. The last thing I'll conclude with is just a brief call, that one of the reasons I used simulated data and not real data, and one of the core things that I'm really pointing to here is we don't have data of sufficient granularity to really say what we know and what we don't know. And so that is sort of one of the persistent ironies in my mind about the big data era, is that it's big data and yet we tend to often have a limited amount of data that's publicly accessible in order to actually be making real sort of assessments in terms of trends in the ecosystem as well as the effectiveness of policy. So I'll end there and turn it over to my illustrious colleague.
Illustrious colleague, not lurking co-founder. Not lurking confounder. Okay, so just as he has offered you some optimism about the state of security today, I'm going to offer you, ironically, given he's the political scientist and I'm more the computer scientist, some optimism about the state of people today. And that is, if you think about the problem with privacy is not that developers don't care, which they don't because they have no reason to do, and people don't care, but rather that people don't know, and therefore developers and companies don't care. And if you think about this from a limits market perspective, this is a very well understood problem, right? So if you think about these apps, which is what we use to manage our own resources, as something like you can't examine it. If you open your map and it says you want your location, yes, I want my location. I just opened my map. What do you think I'm going to say? No, I'd like to search for 7 other apps now and see which resource allocations they give me. That is not feasible. And what we're doing when we get these apps is, like you said, is there's zero risk, is we're making risk-benefit decisions. But the problem is we don't have any information about the risk. We only have benefit information. And if you ask people, as Serge Edelman did at ICSI, you know, how do you know that this is a good, safe app? Is that people actually project risk information into popularity information. And they're completely orthogonal, the resource management issues and the popularity. And the IoT is like the mobile apps market, only with more citrus. You know, we have limited interoperability information. If I buy, so I'm part of this IoT project, and one of the first vulnerability issues we pointed out, this is my colleague Steve Myers bought an Alexa and a smart lock. He was locked out of his house. Luckily, this was Indiana. He went up to his window and he yelled, "Unlock the door! Alexa, unlock the door!" So Alexa unlocked the door. So, you know, and then he did a vulnerability report. Now it's not necessarily something you can do. So not only is risk not well communicated, it is completely contextual, right? Because if the door you want them to unlock is the door to the basement that you keep locked because you have a particularly precocious 4-year-old, yeah, that's fine. But otherwise, no. And then we have multiple decision makers, people who develop apps, the platforms. I think that we could talk more about platforms and the people who buy apps. So how do we get people to care? One of the things that you hear sometimes is people don't care about privacy. They'll give you their password for, a chocolate bar. Well, in those experiments, there is significant lying about passwords, let's be honest, because they don't test the passwords. And then we put people in situations where they cannot protect their passwords. and then kind of say, oh, well, obviously you don't care about privacy, right? I have 1.3 billion password username sets in my lab. All of those were leaked by the trusted parties like LinkedIn, who were supposed to be protecting those passwords. See, maybe people do care. One of the problems we have is risk communication. So I have one of these from Australia. Has anybody here been to Australia? Those cigarette packages are disgusting, so I decided not to share it with you. They're actually a picture of an organ that's like, oh, cigarettes will do this to you. It's like, but this is how we do it, right? So this is, I think I put my favorite one up there. This page appears to be part of a scam known as a phishing attack, in which criminals create fraudulent pages to mimic legitimate sources. Yeah, I think, first of all, phishing. Phishing is the stupidest word ever. Gives you no communication about what it is. I've given up on that. The second, we're talking about 6- and 8-year-olds going on the internet. Did they understand that sentence? No. So this is kind of the computer science version. If we did the smoking with that, a factor which contributes to lung cancer. Here we go. Paraneoplastic phenomenon. Okay, anyway. That's our version. These are our current computer security versions of this is critical. This is Meltdown and Spectre. This is horrible. You have got to address this. Let's be honest, it's adorable. It looks like Casper, the friendly ghost, and he brought the little stick so we can put the marshmallows on it, right? I mean, this does not communicate. All of your files are at risk. We do a terrible, terrible job. And the goal of risk communication is to change behavior. So somebody's going to have to tell me when I'm out of time, by the way. I'm not good at that. Speaking of risk you're taking. And what we want to do is create a partnership. And thank you, developers, fewer permissions, marketplace, want more trust. The thing that the platforms want to avoid is regret. The thing that Google and iPhone don't want you to do is to say, I am sorry I bought this stupid phone. I'm going to buy that other stupid phone. So, and I have a lot of background in here about how people respond in life to risk generally. And the point is that we can learn from this. And you have all the slides that are available. So if you look at this, this is what you see. You see all these, oh, look, it has 5 stars. This is the best. Oh, look, it has 4 stars. This has 50,000 downloads. It is very excellent. But where's the risk communication? There's none at all. So, and this, if you're going to use the app, of course you're going to allow it. You've already made the choice of what app you're going to use. It's like you didn't get any information about what car you're going to get. You get it in a big cardboard box, and then you go out one morning, you're going to get to work, and you're like, hey, is this car okay with you? Now that we've unveiled it and you see what it is, I hope you wanted heated seats. We need better information to provide phone owners. So overprivileging just means that you don't need the privilege that you ask for. That there's this thing called data exhaust in privacy studies. And the idea is that you're just creating data exfiltration. And you're getting data in case you use it. Maybe I want to use it. I might want that. Just like you create waste because you want to use something. And the interesting thing is there are normal and dangerous permissions, and there are also outdated permissions. You have apps on your phone that literally make permission calls that don't work because they're not allowed or because that permission was stopped being used 2 years ago. So developers are not incented. There is no developer incentive to minimize permissions, and there's a tremendous incentive for them to make sure this thing works no matter what happens. Right? It must work. It cannot be stopped because of a permission. And even developers don't understand permissions. If anybody here feels bad about not understanding the permissions on their phone, that's okay. The app developers mostly don't either. And you might think iOS is better, but the only study of head-to-head iOS versus Android apps showed that, now this is legitimate apps, not like stalker apps. Like stalker apps, will be addressed later. But iOS is actually worse in terms of data exfiltration. And how would you know that? Well, you could read papers you could educate yourself as a consumer by reading computer security papers, but I think that is not a legitimate expectation for consumers. I'm not going to read papers about pacemakers if I needed one. We should be able to trust the permission. We should be able to trust the professionals, and we can't. So, counterintuitively, there's irrational overprivileging. So you can say to me, the market's not working. We definitely need to do something about this market. People are doing crazy things. This was my best lemon picture of people doing crazy things, but the point is that actually works. So in 5 minutes, boy, I have a lot more slides than I have 5 minutes. We looked at several different ways of helping people make decisions about phones. And so the first experiment we did was, wait, where are we? Yes, there we were, 4 studies backwards. I'm going to give you 8 papers in 2 minutes. I do this in my economics of security class, and you can do it. It's going to be fun. You ready?
Go.
Go. All right. So the first paper, we looked at short, simple language, your location, as opposed to incredibly complicated language. And then we added eyeballs. Right? Everybody notices eyeballs. This totally failed to work. It was completely perverse outcomes. Okay, so that seemed very reasonable, but didn't work. So we said, how about we try different things? We can try even more evil eyeballs. Maybe those eyeballs were too friendly. These are pretty evil eyeballs. Lock and a smiley face. And then we tried it across a bunch of different apps. See how? You can say bad. You can, like there's our other kind of bad, and there's our locks that are good. They keep you safe. And here's how it's looked in our app. So you have all of this information. We used Amazon Turk. How often do you read preferences? We asked people. People are very careful. They read a lot of preferences, except for this is what they actually did, and the really tall bar is 0. I mean, we mean well. I meant to go to the gym this morning. I mean not to use all my drink tickets, Other risk, we behave the same way. So we did change the decision time in each section, but very, very little. So the regulatory friction was quite little. And all I want you to think here is taller is better. That's not like a normative statement in real life, but so if you gave people locks, they really responded. They were very positive. And then the first choice, when you didn't have to make a trade-off, people still gave up benefits. Shorter blue bar gave up benefits. Taller orange bar got privacy. And when you force trade-offs, it became even more extreme, except for on the far left, which is the control. So if you don't give people any privacy information, of course, they're not going to change their minds. Oh, and do people understand permissions? That would be a no. The unique identifier for your phone, we asked people, this thing says unique identifier. Does it identify you uniquely? 20% of people were like, no, they wouldn't do that. Who would do that? That would be mean. Yes, they do that. So I don't know how much of this is comprehension or belief. So the cue really matters. It really matters how we try to communicate to people. And if you say to people, you're gaining this privacy, you're getting security, your life is improving. If you do this in an intuitive manner, people will choose privacy. And if people choose privacy, then we're all better off. Unfortunately, it was only really a strong effect with priming. So can you imagine you can buy an app, but first you've got to take this survey? I do not think people would respond well to that. That is my belief. So we tried using sound. So if you pick a great app, you got yay, and if you picked a bad app, you got boo, and then you can imagine, wah, very bad boos, and yay, very excited. And so you picked it, and we only use dating apps and puzzle apps for obvious reasons. And again, orange is better. Ironically, my favorite color is purple, but you can see it made a big difference. It makes a difference when you tell people what you're doing. And we did it on MTurk. So a lot of reviews we got said, MTurk, that's not real. So we built a study on the phone that looked like that. We put it on tablets. We routed some phones. And then this is what you got. We just added those tiny little locks. We didn't change the language at all. I know you're all carefully reading that language every time you look at an app because you have infinite time and nothing else to do with your life. So we compared people's responses. We did a Bayesian analysis. So is our group the same? Is it just the pictures? Do people care? What if they really had to give something up? So those were the 4 questions we asked. And so for flashlights, all flashlights are terrible, but they're all terrible in the same way, so they all got the same rating because it was per group. So don't download a flashlight app if you get nothing else out of this talk. So our group is basically the same when privacy doesn't change. So this picture just says, yes, our group was statistically representative. If the risks were different, but the function's basically the same, people chose higher privacy. And this was weather, because it turns out the app doesn't control the weather, alas. So you can see, that was a joke, come on. I can do that. And then we did photos where you have a significant difference. Now, one of the things about photo apps is some of them take your photos and put them on the cloud to process, and others do them locally, and there is no way for you to know that. I mean, you could read computer security papers for that, but I think actually you'd have to hook the phone up to your own network and test it yourself, which is crazy. So again, we found that people made a statistically different choice if they had to make a decision. So then we looked at games, which are very different functionality and very different privacy. We're asking here people to give up benefits, to choose, don't starve over Angry Birds. And we still, it's skewed because the games distribution was a little weirder than the other distribution. There's a lot more apps, there's more privacy variation. But again, we found that people would choose privacy. Our group was likely the same. It was probably not just the pictures, and people do care. And if it really matters, people will still change. So I want to say this does matter, and people will, if we create a self-empowerment situation, if we allow individuals to choose privacy and security, they will. But right now, there's just no way to do it. Is the gentleman from Cisco still here? Oh, I'm totally saying this then. If you wanted to buy a router that had never had a known back door, you really can't. What are you going to buy, Juniper? Huawei, all of them have documented back doors. You just can't. And so I don't know if we can change this in the router market, but we can definitely tell people and change it in the app market. So security is a lemons market, but it can be a real peach. Thank you for your time.
All right.
All the lemon and phone pictures.
We're going to. We have a few minutes for our two speakers to take some questions from you. I will allow you to ask questions entirely at random, deciding on whether or not I like the smile on your face, as opposed to any kind of intellectual judgment related to the content of your questions. So, does that make sense to you guys? Is that the most appropriate academic approach to use? I'm just an adjunct, so I don't really know. I don't have the same pedagogical training that you do to professionalize Q&A. So with that, For either of our distinguished speakers, do we have some questions?
When looking at the data trending that things are potentially getting worse, that you need more granular information on, does that suggest, like the guy from Samsung said 100% of their products were going to be IoT ready by the year 2020. Does that mean we need new products to address that, or just new safety procedures?
So there's a twofold answer there. There's the measurement question, which I'll get to, and then there's also the sort of policy response side of it. So from the what will all devices being IoT enabled do to observed aggregate trends, that should easily satisfy all three conditions all at once, and we're going to have worsening aggregate trends for sure, and even more of a chance of Simpsons Paradox emerging. So right away, the massive introduction of IoT is likely to be pretty distortive because it's highly vulnerable and there's lots of them. In terms of responses to try to deal with that, I think that there is what's been covered during the course of today. You've got this combination of standards and policy responses, but you've run into issues of jurisdiction, in my view, because you have cross-border technologies and networks faced off against national jurisdictions and national abilities to regulate. So there has to be some sort of multi-stakeholder global type solution. But when I asked earlier about this, the after the fact solutions to some of these problems, I think product liability is going to be a big one. As you integrate into physical systems, eventually you're going to start to have things where people will get hurt and people will start suing, and then that's going to really force the ecosystem. All the preventive measures I think are great, but it's going to take a few bad things to happen and then product liability to start kicking in for this to really get traction, would be my sense.
Another question? Yes, please. Hold on, microphone's coming to you.
Can I make one comment while the microphone's getting there? Samsung has a 15-year certificate certifying their hardware. He did not mention that it uses a deprecated hash function, SHA-1. I know who knows it because I saw the flinches. So if he doesn't change that, they could be huge contributors.
Thanks for your presentation. My name is Li Yang. I have two questions. One is for the students and the schools. The other one basically from the preference of consumers. So let's say for the first one, currently the school system is basically run by the administrative staff rather than by teacher. So administrative staff, they might say, they want to hire a psychologist. So by psychology, they will interact with the student. They get the students, the family situation, everything, sort of very privacy into the school system. Then they targeted, the family will be targeted by school staff. So I wonder if you have a study of this type of things about their school system and the evaluation, where the school, the teacher, and the student will be kind of devaluated, even if you are high performers, but you will be devaluated, your family will be devaluated. The second is the preference. The consumer preference is supposed to be very significant in terms of choices and how the society or market go to the competitive situation. Now the current system, especially in a complaint or administration, whether it's administrative level or judicial level, the litigants, they don't really have a choice. Once you go to the court, it's the court personnel that decide everything. They don't even allow you to have a transcript or tape. So any study of this sort, the marketplace supposed to be, say, consumers' preference should be the high preference rather than court personnel to decide your case.
All I can say about the current administration is that I am trying to work with platform providers. And I feel that corporate leadership is needed.
Well done.
Thank you.
And on my side of the education, I don't know a tremendous amount about education policy besides the bit about the Nation at Risk report. So I was using that just illustratively because it's an instance where Simpsons Paradox has happened and policy changes have been enacted. So I'm not sure about the current lay of the land.
As faculty, we agree that we are superior to administrators.
Yes, that, wait, wait, I don't have tenure yet, so I'm but yes.
While we're looking for another question, can I pose one? We're attempting to monetize cyber risk. Do you see any evidence, this is for Eric, do you see any evidence that insurance companies understand Simpsons Paradox? Because they're trying to price cyber risk and monetize cyber risk and price cyber insurance. I haven't been myself particularly sanguine about the foundation for which they do it. I think I know where they're getting some of their pricing data, and I won't describe where I think they're getting it in this room with this particularly distinguished crowd. But do you think that they have any sense of the difference between aggregated and disaggregated data in how they're pricing this cybersecurity insurance as a product?
So, I mean, there's a lot of very competent people working at the insurers trying to figure out cybersecurity, how to price cybersecurity risk. However, I'm skeptical at this point about how accurate their risk actuarial tables are going to likely be. There's problems of aggregation bias. You have other problems, for example, failure to normalize statistics. So we almost never, in all the aggregate trends that I pointed to before, we use counts. So how many records were breached, how many firms were breached. And in the physical world, we never do that. We talk about rates because they make more sense, because a larger population has more events. And so even basic sort of manipulations like that, manipulations in the sort of statistics sense of the term, are missing in a lot of how we talk about these issues. The insurers, again, they're competent people, and a lot of them would probably putting a lot of effort into figuring this out, but I think there are issues with availability of data, and there's also the problem of how well can you predict future events based on past data in a world that's likely pretty non-normal in terms of the distribution of events. If it is a power law world like I modeled in the second table there, those are worlds wherein you don't have stable means, you end up with these huge fluctuations, and you could have a pricing scheme that's going to totally overlook the fact that the next big breach is going to be 5 billion people.
Well, I think that's right. What you hear in the policy world here in Washington is everything is getting better despite all the money we're spending and all the work we're doing. But it's not absolutely clear that the data that would support that assertion is reliable, in that I can understand that the threat is getting worse. Why is nothing that we're doing seeming to make the situation better? And I'm not entirely sure that that's true. But I don't know, but I've been looking for a basis under which to challenge those assumptions, and so I thought your presentation was interesting. Other questions?
Well, I'll go ahead and answer your question to him also.
Please.
If you think about the role of insurance companies in other domains, they require you to implement some basic functionality. You must have, sprinklers, and they literally send inspectors to, raise the roof tile and look at the sprinkler and make sure the pipe is connected, because honestly, sometimes it's not. We don't have that same structure in cyber risk insurance, even though we know that there are one or two things that every organization should do. Every organization should be using two-factor. If you don't want to be phished, use two-factor authentication. Little tiny things, they fit on the key ring, they work with people's mental models. If the insurance companies would embrace some of this low-hanging fruit, I think we would be in a much better situation, particularly when you look at things such as phishing.
Right. We can take one more question, I think. Yep. I thought I saw a hand up.
Sam, I'll take it if I may. So maybe staying on the insurance piece, how do we help insurers and related parties get the data that they need? And then second, in terms of mental models, labeling IoT devices is popular. How do we make that doable given the amount of data that kind of underlies those IoT labels?
So the second question first is that you can do an analysis of the device and of the hub, which is not at all infeasible. Consumer Reports is doing these analyses. We've looked at hubs in our lab. You can look at the way they interact. And it's true that and then you also have to look at the app that's associated with the IoT device. And yes, it requires static and dynamic analysis, but the way that we evaluate cars, which are far more expensive than hubs, includes we run them into walls and repeatedly. So it is clearly not beyond our ability to provide a uniform, consistent rating. And I think the biggest barrier to that, honestly, in my opinion, is that we in computer security have a belief that there's a difference between data that are exposed because it's a privacy breach and data that are exposed because it's a security failure. We don't care what particular form of force, oh boy, when I wreck my car, I'm really concerned if it's, rotational momentum or direct forward Newtonian force that makes my airbag. No, you care if your airbag explodes. And I think this bifurcation about privacy versus security has really gotten in our way.
With that, let me ask that you thank our panelists, and thank you very much. Very thought-provoking, excellent comments as well. Thanks.